what we know today is that these diseases happen over decades. And as a result, we need to be implementing daily practices to offset that decline, because you won't see your blood vessels starting to become less, have less integrity. You don't see on a daily basis that blood does not pump from the heart as well as it should. You do not see immediately, but only after decades of damage do you start to see cellular decay and cellular decline. Because where did we start today? That your body is an amazing machine. And that amazing machine has been course correcting for decades. But at some point, due to overwhelm, at some point, due to the senescent creation of cells in the body, right? Due to lifestyle that kind of puts the gas pedal down, we start to see aging decades before we are supposed to. We start to see disease or decline decades before we are supposed to. Obesity is epidemic in our countries. Cardiovascular disease is still the number one killer of both men and women in our countries. Concerns with blood sugar, some of the number one concerns in our country. And they are rooted in inflammatory cascades and free radical cascades. They are rooted in what we are talking about here today. Too many free radicals, too much oxidative stress, too many years on the planet, and too many years on the planet exposed to toxins, and not enough healthy fruits and vegetables, not enough movement and stress management, and not enough concentrated antioxidant support like can be offered in OPC3. OPCs are the most powerful natural free radical neutralizers. Let me explain to you why. Free radical neutralizers come in all kinds of different shapes and sizes. OPCs, that oligo part of the word, oligomeric proanthocyanidins, the oligo part of it means branched. It means multiple. It means many. Many free radical scavengers out there are not complex. They are simple structures. I liken this to a knot. Have you ever tied a knot? Maybe a necklace has gotten knotted up, right? Your child's shoes or your parents' shoelaces have gotten knotted up, and you're the one that has to figure out, what did you guys do here? How did this happen, right? The unknotting of that takes time. The unknotting of that takes effort. The unknotting and the creation, right, of the straight line or the straight lace or the straight necklace or bracelet, right, takes effort to line everything up again. That is what free radical scavengers do for us. That knot is now flipped over. That knot and how long it takes to get through it is the nature and complexity of an OPC3, right? Unlike vitamin C, which is amazing, right? But it is a far more simple free radical scavenger. It is not as powerful at neutralizing things like chlorine in your water, right? It is not as powerful at neutralizing toxins and chemicals that have found their way into your air, your food, your water. What you need is something that is so complex, like that knotted knot or that knotted necklace that takes effort to get through. You need something that is so complex, so complicated that it can, that the same, like we're liking it to, how long did it take you to untie that knot? That is how it works with OPCs, where they function in the body for a long period of time. They're so complex, it takes a lot of metabolic hits to finally break them down. And what that means is for a longer period of time, they are able to create a free radical balance within the body. They are so complex, so complicated in their structure that it takes effort and many free radical pings or anatomic steels, as we're going to refer to them tonight, to actually break them down. And that means that they're functioning at a higher level in the body, higher a higher level than many other free radical scavengers. So they are considered the absolute peak of free radical scavengers because of their complexity. But that complexity adds another level of free radical scavenging, and that is donation. If the whole idea here is to balance a free radical cascade, if the whole idea here is to make sure that this cell is stable and this cell is stable, well, they want to steal from each other, right? OPCs come in, and because of their complexity, are able to constantly share their own electrons to stabilize these cells. But they do something else. They also donate their electrons to vitamin C. They also donate their electrons to things like ORAC. They also donate their electrons to things like green tea and the foods that you eat. OPCs can also amplify other supplements that you take by sharing their electrons. And this is a constant recycling that will happen in the body. Not only is cellular decay coming in from the outside, from the inside, not only are free radicals and toxins coming from the outside, OPCs are playing like tennis with that, right? OPCs are coming in and they're quenching all of that, but then they are also taking natural body metabolism and they're amplifying it. That's that senolytic property that we talked about. They're making sure that cell cascades, that natural energy cascades, also have an abundance of free radical of electrons, so they can be free radical scavengers, and metabolism can keep going at this rate, not at this rate, right? And so that's the power of OPC3s. Not only are they so complex that they take time to work through and therefore can scavenge free radicals for a long period of time, they also work to recycle other antioxidants in the body, whether those are metabolic antioxidants like detoxification pathways, or those are supplements that you're taking or diet that you're implementing. OPCs can amplify the free radical scavenging capabilities of your diet, as well as other studies. In fact, laboratory studies show that OPCs are more powerful antioxidants than vitamin C and vitamin E, but can make vitamin C and vitamin E more powerful by constantly recycling them because of how complex OPCs are. And that's why we put multiple illegal